On July 29, 2025, Earth didn't just tremble, it shifted. A monster, 8.8 magnitude earthquake struck off Russia's Kamchatka Peninsula, and in seconds, it changed the planet. It moved mountains, redirected oceans, and, perhaps most astonishingly, altered Earth's rotation. But the most fascinating part? That was just the beginning. Chapter 1. Ground Zero. At precisely 11:24 a.m. local time, the Kuril-Kamchatka subduction zone, one of the most volatile fault lines on the planet, ruptured. It was the kind of geological event scientists warn about, but rarely witness. Along a rupture zone 480 kilometers long and 160 kilometers wide, the Pacific Plate violently thrust beneath the North American Plate. In places, the crust slipped by up to 9 meters. Imagine a 3-story building collapsing in a single instant. That's how much the ground moved. Because the earthquake originated just 20 kilometers beneath the ocean floor, that seismic force displaced an enormous volume of water. Within minutes, tsunami alerts lit up across the Pacific Rim. Alarms sounded in Japan, Alaska, California, Chile. Anywhere near the Pacific Basin, people fled to higher ground, expecting disaster. And in some places, it came on Shamshu Island. Waves reached a towering 19 meters. Entire fishing villages were battered. Boats were hurled inland like toys. In Severokurilsk, floodwaters surged more than 200 meters inland, damaging infrastructure and forcing over 2,700 people to evacuate. But elsewhere, the waves were gentler. Most coastlines experienced surges closer to 1 meter, serious but not catastrophic. The world exhaled a collective breath of relief. 4 people were injured. No one died. A miracle. But while the surface appeared calm, something strange was brewing beneath our feet. Chapter 2. A planetary shift. As the dust settled, satellites and atomic clocks began picking up anomalies. Not in the oceans, not in the skies, but in the planet itself. The Kamchatka quake had shifted Earth's mass. That's not poetic, it's literal, like a spinning top that wobbles when you adjust its weight. Earth's rotation changed. The quake shortened the length of a day by several microseconds, too small to notice, but large enough for NASA's most sensitive instruments. And it moved Earth's figure axis, the balance point of its internal mass. This wasn't unprecedented. The 2011 Japan quake and 2010 Chile quake had done something similar, but each time, the message becomes clearer. Earth's crust isn't just breaking, it's adjusting the planet's balance. Southern Kamchatka physically shifted over 2 meters southeast. An entire chunk of land moved. GPS stations blinked with the updates. This wasn't just a shake, it was a shove. Chapter 3. The Data Goldmine. What made the Kamchatka quake so extraordinary wasn't just its force, it was the precision with which it was recorded. Never before had a megathrust event been captured in real time by such a vast global array of instruments. Ocean buoys recorded wave propagation within seconds. Deep sea pressure sensors logged seafloor movement. Satellites detected gravitational field shifts. Even hydroacoustic sensors picked up vibrations in the ocean. The result? A seismic fingerprint unlike anything in history. For geoscientists, this was a goldmine. With this data, they can model not just earthquakes, but the planet's response to stress, how tsunamis ripple, how tectonic plates flex, how even the smallest tremors contribute to massive chain reactions. And this time, those reactions reached far beyond the quake zone. Chapter 4. The Cascadia Connection. Half a world away, the Cascade volcanoes of North America began to stir. At first it was subtle. Seismographs detected faint rhythmic pulses, repeating every 11 minutes, too soft to feel, but too regular to ignore. From Mount Baker in Washington to Mount Shasta in California, more than a dozen volcanoes seemed to ping in sync. Scientists at the Pacific Northwest Seismic Network couldn't believe what they were seeing. The pulses were faint but synchronized, as if the entire volcanic arc had been struck by a tuning fork. Then came Mount Rainier. Less than 24 hours after the Kamchatka quake, a swarm of long-period tremors began beneath its southeastern flank. Within minutes, similar tremors appeared under Mount St. Helens, then Mount Hood, then the Three Sisters. What was happening? Chapter 5. Not just aftershocks. Initially, scientists thought these were ordinary aftershocks, or perhaps noise from the Kamchatka event. But this wasn't random vibration. It was organized, rhythmic, It had timing, 11-minute intervals, coordinated across hundreds of miles. The USGS convened an emergency review. The verdict? These were transient tremor-like signals. Not enough to indicate an eruption, but enough to suggest something deep was shifting. One scientist described it as a planetary whisper. Matched filter analysis compared the pulses to decades of archived seismic data. They didn't match eruption tremor. Instead, they resembled deep, slow-slip earthquakes, movements that happen along hidden faults, silently and often without warning. Chapter 6. Earth's Hidden Orchestra. The hypothesis? Planetary resonance. A megaquake like Kamchatka didn't just send shock waves through the crust. It rang the entire planet like a bell, and the Cascades, with their complex magma systems and fragile geology, responded like tuning forks. Dr. Tessa Nakamura described it like this: "It's as if the Earth struck a chord, and the mountains hummed back. Sensors even picked up sympathetic vibrations in Japan's volcanic arcs. Minor pulses were recorded in Indonesia and parts of the Andes. It was as if the planet itself was synchronizing." Chapter 7. A New Kind of Risk. Then came more clues. Mount Rainier registered over 1,300 microquakes in the following weeks, the most ever recorded in that time frame. Mount Shasta emitted low-frequency noise not heard in years. Newberry Caldera's geothermal heat ticked up. Even the oceans responded. Hydrophones captured low rumbles beneath the Cascades. But no eruptions, no lava, no gas plumes, just tremors, signals, echoes. Was the planet simply flexing, or was something bigger stirring beneath the silence? Chapter 8. Humans are shifting. Earth too. While the Kamchatka quake showed us the planet can shift in seconds, humans are reshaping it every day, just more slowly. Studies show that excessive groundwater pumping, especially across India and China, has shifted Earth's figure axis by nearly 80 centimeters since the 1990s. That's more than most earthquakes. We're also melting glaciers, rising seas, damming rivers, redirecting the weight of water and rock. Over decades, this changes Earth's mass distribution. Our actions are altering how the planet spins and balances. And unlike earthquakes, our changes don't stop. They compound. Chapter 9. A Living Planet. The Kamchatka event proved something we've long suspected, but rarely see. Earth is a living system. It groans, it flexes, it responds. And sometimes, those responses aren't isolated. They echo. Satellites now adjust for the shorter day. GPS networks recalibrate for the shifted land scientists' race to understand what it all means. And the volcanoes? They've gone quiet again. For now. But the signals they sent, those rhythmic pulses, are burned into seismic memory. July 29, 2025 will go down as more than a natural disaster. It was a planetary reset, a moment when Earth reminded us who's really in charge. For scientists, it was a gift, data that will refine models for years. For the rest of us, it was a wake-up call. Earth isn't still, it isn't predictable, and it certainly isn't done moving. So what happens next? Will another megaquake trigger a similar chorus? Will the next planetary pulse bring magma to the surface? We don't know, but one thing is clear: the planet is talking. We just have to learn how to listen. If this opened your eyes to Earth's hidden power, subscribe to Geosphere. Because this story is just the beginning, and the planet, it's still speaking.